Solve the equation of 5 tan theta minus 1 equals 0 for theta to two decimal places, where theta is greater than 0 but less than 360 degrees. To solve this problem, we want to use our 4 steps below, where step 1 is to solve for our trig equation. In the question, we're given our equation of 5 tan theta minus 1 equals 0, but we want to isolate for tan theta. So we add 1 to both sides, and we have 5 tan theta equals 1, and then we divide 5 by both sides, and we're left with tan theta equals 1 over 5. So now that we've solved for our trig equation, let's move on to step 2, where we identify the quadrants. As we can see, tan theta equals a positive ratio. So we want to put our reference angles in the quadrants where tan is positive. We know all trig equations are positive in quadrant 1, and in quadrant 3, only tan is positive. So we have our reference angles in quadrant 1 and quadrant 3. Now we want to find the values of these reference angles. To find this value of our reference angle, we want to solve our equation of tan theta equals 1 over 5. Now because we're not dealing with exact values, we need to use our calculator to solve. So to solve for theta, we want to take the inverse of tan of its ratio 1 over 5. And plugging this into our calculator, we get a value of 11.31 degrees as our reference angle. So filling this in on our graph, we now have our reference angles 11.31 in quadrant 1 and quadrant 3. Now that we've found our reference angle, let's use the graph to find our solutions. So as we can see on the graph, we have terminal arm 1 and terminal arm 2. Starting from 0 degrees, we have our standard position angle, we'll label that theta 1, and we have our second standard position angle, and we'll label that theta 2. As we can see, theta 1 is simply the reference angle because it's an acute angle with 0 degrees. So we can say that theta 1 equals our reference angle of 11.31 degrees. But theta 2 passes 180 degrees. So to find theta 2, we have to add 180 degrees to our reference angle of 11.31 degrees. And adding these two values together, we get a standard position angle of 191.31 degrees. So we solve that theta 1 is 11.31 degrees and theta 2 is 191.31 degrees as our final answer.